Today we're going to be discussing balancing equations. The law of conservation of mass tells us that the mass of the reactants is equal to the mass of the products. And if you remember, that means type and number of atoms on the reactant side of the equation will be the same as the type and number of atoms on the products side of the equation. That doesn't mean you have the same compounds though, because atoms will change, they will rearrange themselves. We discussed briefly photosynthesis, where plants take carbon dioxide and water from the atmosphere and from its environment, and they rearrange those carbon, hydrogen, oxygen atoms into what we call a simple sugar, and they give off water and oxygen. And remember, the simple sugar is C6H12O6. So you have the reactants, the number of the reactants equal the number of the products. So what does that mean? That means when we look at an equation, we have to say, hey, are there the same amount of hydrogen atoms on this side as there is on this side of the equation? And is there the same amount of oxygen atoms on this side as there is on this side of the equation? And if you look at this equation, I'm just going to draw a T-chart, and what I do is I count up. I say, oh, there's 2 hydrogen here and 2 oxygen. So I box it up and I count. And on this side, I have 2 hydrogen and only 1 oxygen. Alright, so I can see that this is an unbalanced equation. And the way to solve an unbalanced equation is to isolate one of the elements and try to balance it. Okay, so in order to balance it, we can only add coefficients. We can't just change and add in another subscript, because that would change what the compound is. That would change the ratio of atoms in the compound. Okay, so instead, water molecules have a ratio of 2 hydrogen to 1 oxygen. So if I added a 2 down near the oxygen, that would be 2 to 2, or 1 to 1. Okay, so the ratio would change. It wouldn't be water anymore. So we can only add coefficients to balance equations. If you notice, the hydrogen's balanced, so the oxygen's imbalanced. So we isolate this oxygen over here. Now we have to figure out a way to make this 1 equal to 2, and what times 1 is 2 is 2. But in order to make that oxygen become a 2, we have to add the 2 in front of the entire molecule, which means it's going to change not only the oxygen, but the number of hydrogen atoms as well. Okay? So you end up with 4 hydrogen atoms and 2 oxygen atoms. Now, the oxygens now check out, but now the hydrogens are out of whack. So let's go back and try and figure out how we can isolate and fix the problem over here. So if we have 2 hydrogen atoms here, how can we make it 4? Well, what times 2 is 4? That's 2. So in order to multiply that by 2, we have to add the coefficient of 2. It is distributed to the subscript, and it is 4. And now they check out. You then have the balanced formula, 2H2 plus O2 equals 2H2O. And if you count up the number of atoms on this side of the equation, they will equal the number and type of atoms on this side of the equation. You'll have 4 hydrogen here, you have 4 hydrogen here, you have 2 oxygen here, you have 2 oxygen here. So that is a balanced equation. Let's go back and look at the steps that I took in balancing those equations. And we'll start with a couple of them and follow a process. First of all, let's look at this. We have Na plus I2 yields NaI, sodium iodide. So the first step that I like to do is I like to create a T-chart. So I draw a line right down the middle, and then I box and count the atoms. So on this side, I have sodium, which means I know I'm going to have sodium on the other side because it's always the same type of atoms on either side of the equation. And I like to keep them lined up. So I have sodium and iodine. And here I have 1 sodium and 2 iodine. Over here, I'm going to have sodium and iodine as well, but I only have 1 of each. So what's out of whack? Well, the iodine's out of whack. So let's isolate the iodine. How do I make this iodine become 2? Well, I have to add a coefficient of 2 in front of the entire compound, and that distributes it, which means it's going to multiply the sodium as well. So now I'm going to have 2 sodium, 2 iodide. Now my iodines check out, but my sodium is now out of whack. So how do I convert this to 2? I put a coefficient of 2 in front of it, and it becomes 2 atoms of sodium on either side of the equation. We try to add the smallest coefficient possible, so the least common denominator is our goal here. Alright, now let's do another one. Alright, we have nitrogen and oxygen, box it, nitrogen, oxygen, We have 2 nitrogen here and 2 oxygen here. We have 2 nitrogen here and only 1 oxygen here. We isolate this oxygen, and we're going to try and balance it off with the other oxygen. So in order to do it, I have to get 2 of them. So I have to make it at least a coefficient of 2. So that times 2, but now this converts this nitrogen to 4. So the nitrogen over here is out of whack. So now I'm just going to go balance that one. Okay, so 2 times 2 equals 4. So that means I'm going to have to add the coefficient of 2 up here. And this coefficient went here. Alright, and if I count them up, 4 nitrogen on either side, 2 oxygen. Okay, here's another equation. T-charted up. We're going to box and count them. So you have potassium, chlorine, and oxygen over here, which means you're going to have potassium, chlorine, and oxygen over here. And let's count up the numbers of atoms of each. You have one potassium here, you have 1 chlorine, and 3 oxygen. Here you have 1 potassium, 1 chlorine, and 2 oxygen. We're going to isolate the oxygens. So how do we balance the oxygens? Well, let's look at it. It's 2 and 3. So what's the least common denominator of 2 and 3? That would be 6. Okay? So I'm going to isolate this one. Find the least common denominator to make it balanced. That's going to be 3. Okay? This one's going to be 2. Okay? So I'm going to add a 3 here and a 2 over here. But that means all of these are going to change too. Alright? So this equals 6. This is going to equal 6. So that's balanced. Now, what's out of balance? Potassium and the chlorine. Okay? So now you have 2 and 2. To make let's isolate the potassium. In order to make that 2, you multiply by 2. Alright? But when I do that, I'm going to multiply this by 2. And it's all balanced out. So the trick to balancing chemical equations is trying to find the least common denominator and putting that as your coefficient and working out the problems. And sometimes you're going to have to go back and forth from side to side and isolate one element, balance it, then isolate anything else that becomes unbalanced, one at a time. So just to recap, the steps to balancing equation. 1, set up the T-chart. 2, box and count each element, okay, each atom. Isolate a single unbalanced atom and balance it. And then add the smallest coefficient possible until the number of atoms is equal on both sides of the equation. If you have any questions, please write them down, bring them into class, and we can go over it as you work on your notebook and lab activities and other activities in the classroom. Okay? We'll see you tomorrow. Have a great night.